Our history class had us explore different kinds of major disasters. They are either financial, chemical, political, economic, organizational, but all have in common people have suffered from them, and they should be prevented in the future by learning from our mistakes and adopting educated measures. We elected for our project to look at the famous chemical gas leak that happened in December 1984 at Bhopal, India, and Professor Nosheen Gothard, Ph.D. in chemistry and chemistry lecturer at IIT, will be analyzing the event and the aftermath with us.
Yeah, so there was a Union Carbide Limited, which has two branches in Virginia, USA, and then India. And that's what, when I studied Union Carbide case, when I was trying to investigate what kind of intermediate they could have used instead of metal isocyanate. So what they used to do is used to combine metal amine to phosgene and make this really poisonous intermediate, which was MIC. So once you have this intermediate, you can then attach it to this naphthol and form the pesticide. So what happened on that day of disaster is the first step of this reaction is actually dehydration. So water has to come out of these chemicals to react. What accidentally happened is the pressure of their water tank and the chemical tank or ingredient tank were imbalanced, and water, instead of going out, it went back into the reaction chamber, resulting in the huge increase in pressure and temperature, about like 200 degrees centigrade above the norm they would have had, and that causes the leak. And as a result, that the 3 metric tons of isocyanate, which is a really, really toxic intermediate, escaped from the tank. And on top of it, the safety valve, which would have neutralized that intermediate, were turned off because they were trying to save money. Because it was branch of Union Carbide Limited, which was based in US, and all the employees has to come to US and they had to get trained and then go back work there. What Indian administration did, they actually, instead of having 3 supervisors and 12 workers, they reduced the number down to 1 supervisor and 6 workers only, just to save money and get cheap labor. So once they did it, the workers had to work more, long hours, so they look out for other opportunities, and most of them left. So what they did on top of it, they hired less skilled people instead of like highly skilled. So people who were working there weren't supposed to be in a chemical plant. They just didn't know how to react after that catastrophe happened. They did this normal thing like any I or you would do. If you see a huge leak, you would just try to cover it. Covering was not the answer. They had to neutralize what was leaking to stop them from spreading. I would call it world's worst industrial catastrophes. It made me tear up when I watched the documentaries and as I was studying to see how chemicals can affect a human life. Being a chemist, we deal with it every day. I have personally handled MIC many times, knowing sodium cyanide, but knowing that what it could do if exposed to atmosphere, what harm it can do is just devastating. So I think it's up there, on the scale of like Titanic. They were using overly sized containers. So like if you guys have been to chemistry lab or anywhere, when you dispose anything, always you see a level that you don't go above that level. Otherwise the safety officer won't take it. And these containers were way above the safety level. So there was another problem. Why water went back into the reaction chamber, because they were overfilled. So if the reaction was more than 100% yielding, there is a chance that the rest of the material would go back into the reaction chamber. And on top of it, when the temperature increased to 200 degrees, the refrigeration system which was installed on operation scale was turned off just because they were trying to save money. So they didn't care about adding like dry ice, which makes things cooler, to that chamber. So that didn't help. Okay, so what happened immediately after the gas started leaking? So now we are looking at this metal isocyanate intermediate, which is a gas. It right after it escapes, just think of it, it's a really tiny scale. But here we are talking about in metric tons. But even in the small scales, right after it escapes to the atmosphere, what is there? There is carbon monoxide, carbon dioxide, we have clouds, and those are not good news. They are all reacting to form even more poisonous gases. So you have water and phosgene, what already there, they're reacting carbon monoxide, and as a result you form toxic gases like hydrogen cyanide. And all these gases are heavier than oxygen. So the whole area was filled with these gases instead of oxygen, and oxygen was above. So animals, plants, any life was just breathing these toxic gases instead of oxygen. So you can imagine property damage was another thing, that everything was just contaminated. They could not eat anything out of that environment. No vegetation, no sea life, nothing, because everything was contaminated for years. When people started breathing this toxic gas, the immediate reaction was coughing, vomiting, severe eye irritation, suffocation, right before they started dying. And then the long term, if they were far enough from the gas leak to not choke, then they had lung problems and other kind of edema, and going years and years, they had reproduction problems, stillbirth, and all kinds of diseases coming out of this gas leak. They knew they did something wrong. Just like if you catch a thief stealing something, the first reaction, they panic. They won't give you any information. So that's exactly what Indian government did. They didn't let any investigators in their plant, which would have or could have helped them stopping that danger. Because now you have this gas leak, but what about all the chemicals already in their tanks? Isocyanate, they were storing 42 tons already, and they didn't care about disposing it. When they decided to dispose it, there come another catastrophe, just trying to dispose that chemical. If they would have taken help and more qualified safety precautions, then those emergency action plans like we do in US could have been applied there, and it would have caused less, not 2, but I would say 40% lives would have been saved. Their instant reaction was like as if they were caught doing something wrong, because all the things that they didn't follow what they were supposed to, hiring less people, less skilled people, shutting off all the plants refrigeration units, and their vent gas scrubbers, which supposed to neutralize that gas. But then they started cooperating when they realized that gas is hurting their own people. And when they cooperated, then what good things came out of it. The first was the economic rehabilitation with the US. After the US helped and gave them all the funds that people needed for their debt claims, like $25,000 to their families, even though they have lost lives, but at least they had something to fall back on. And the 1990 interim relief, and how to deal with all that mess that had a chemical plant has created. They disposed the poisonous intermediate and neutralized them, which they're supposed to spray caustic soda. So they had to come out with that many tons of caustic soda to neutralize that much of material that was in their tanks. So that was the scope that I, as a chemist, come in the picture. That how can you avoid using in metal isocyanate? And there are ways. If there is a will, there is a way. Why can't you use different reactants? Why can't you use different paths and go to the same route and take the same material out of it? So see, what they were doing, they were combining methylamine to phosgene. So they are making this MIC, which is a poisonous intermediate. And after this poisonous intermediate is formed, it then react with this phenol and form their desired product. The only simplest thing they could have done is to switch the order of mixing reagents. So what I suggested that they could have done is take the safer naphthol and added phosgene here instead of using methylamine. So they could have avoided this intermediate. Instead, this is a safer intermediate, which doesn't cause that many gases, and then go to the same product. And there are many other million ways they could have done it. But this is what I thought would be the most safe. I actually wrote algorithm, which is, so because these chemicals are all in chemical databases, so what I did, I wrote an algorithm which could detect intermediates like MIC, and then I asked, okay, now computer go in and find me pathways where this intermediate is not present, but the product is. And then it came out with a bunch of reactions that could have been done and to avoid this toxic intermediate and coming from the safer path. So what could have been done? Obviously, they would have had their plant operational like it's supposed to. If you are making something poisonous like MIC, the reacting chamber has to go into the condensation chamber where they are doing dehydration of water, which was turned off. They should have kept it off. And after when these type of industrial operations are occurred, there has to be vent gas scrubbers who actually spray neutralization material right after any gas leak, which could have happened if you're dealing with any toxic material like this. It starts spraying, so it neutralizes right after it escapes from the chamber, so it doesn't go into the atmosphere and cause that much trouble. My answer would be stop using poisonous intermediates. If there is a safer way, do that.
We realize over and over that the main disasters we have faced are much more than the obvious superficial cause. Bhopal is indeed not an exception to the rule, because like we just learned with Professor Gothard, financial reasons had not only pushed the administration at the pesticide plant to operate with 1/3 the normal and recommended personnel, but also this reduced staff did not go through the correct training to prevent simple situations that needed to be addressed. The Bhopal disaster lessons can be extended to a broader range of circumstances. If we want to be socially conscious and prevent unfortunate accidents of any sort, we must at some point be responsible enough to disregard the capitalistic urge to make more and more money no matter what, make the right decisions to predict and control what can be.